Hello guys, you're welcome back to my channel, Fun with Physics. In this lesson, we are going to consider temperature and heat. How can you tell if an object is hot or cold without touching it? Thermal imaging is one of the techniques you can use to be able to determine if something is hot or cold. It's a technique of using a heat produced by an object to produce an image of it. We sometimes use the heat given off by the object to determine the location of the object. We have a thermal image here of a person holding a scorpion, which is a cold-blooded animal. Now notice the variation in color. For a black color, the temperature range here shows a reading that is way below 17 degrees. For a blue color like what we have in the background here, the temperature shows a temperature range within 21 to 17 or 17 to 21 as the case may be. For a yellow color, the temperature range falls within this region here, 28 to 31 degree. And then the red color, the temperature falls within this range, 32 to 36 degree. Okay. Now a white color depicts a temperature that is way above 36 degree. Now what is the difference between heat and temperature? For us to find out the difference, we need to look at this, examine this closely. Here we have a pot that is being heated by a hot or a burner here to a certain temperature, let's say 100 degree. And then the next one, we have a thermometer that is inserted in the water to be able to tell the particular temperature. Okay, so while the burner supplies the thermal energy needed to raise the temperature, the thermometer is used to determine how hot or cold the temperature of the water is. So we can say that heat is transferred to an object. It's a form of energy that is transferred to an object, like what we have here. Okay, it's transferred to the object. While temperature is the measure of how hot or cold the object is. So in a nutshell, we can say that temperature measures the average kinetic energy of a molecule, but heat measures both the kinetic energy and the potential energy of the molecule. The instrument that we can use to determine the temperature of an environment or a place or an object is this. It's called a thermometer. We have different types and ranges. Okay, we have the clinical one. That's a liquid in glass here, the clinical type. We have the mercury type, we have the alcohol type, and so on. We have the digital also, and so on. It is for the liquid in glass, we have basically four parts that are very, very important. We have the bulb, we have the stem, and then we have a narrow bore, okay, or tube inside where the mercury can rise. Okay, so when you insert this thermometer in a hot liquid, for instance, or you put it in a particular environment, the mercury expands and rises, okay, by the action known as capillary action to a certain point through the bore and stops. Wherever it stops, you can read off as the temperature of that environment. Okay, so this specific one here is used to determine the temperature of a human body, since the maximum reading here is 42 degrees. The heat can only flow from a region of higher temperature to a region of lower temperature. Remember what I said about temperature as a measure of the kinetic energy. So we can say here A has more kinetic energy since the particles are vibrating more than B. B has less since the particles are vibrating less. Notice the particles here are close together, but these ones are way far from each other. Okay, now when you bring A and B together, heat transfers from A, where we have more kinetic energy, to B, where we have less kinetic energy, until both of them reach a common point or a common temperature known as equilibrium temperature. Now, the summary between temperature and heat. Temperature is the degree of hotness or coolness of an object, like what we have here, while heat is a form of energy called thermal energy. Temperature is measured in Kelvin or in Celsius or in Fahrenheit, but heat is measured in joules. We can measure temperature using thermometer, but we can determine heat transfer to an object using a calorimeter. The temperature does not depend on the amount or quantity of material. For instance, a swimming pool can have, water in the swimming pool can have the same temperature as water in a small cup. But heat depends on the amount of material, okay? For instance, water in a swimming pool can store much more heat energy compared to water in a small cup. Temperature measures the average kinetic energy of a particle, and then heat measures the sum of not just the kinetic, but also the potential energy. Temperature is a fundamental quantity, and then heat is a derived quantity. Now, from particle theory, we know that nothing remains fixed except at absolute zero. All particles, all matter vibrate or move in one way or the other. For instance, solid, the particles tend to vibrate about a position. Okay? And in liquid, the particles tend to slide over each other. And then in gas, the particles move randomly. Okay? In the process, may collide with each other. Okay? These goes a long way to tell us that nothing remains fixed, nothing stays stationary, okay, except at this temperature, the absolute zero, which is negative 273 Kelvin. Now, when you heat a solid, a liquid or gas, you are increasing not just the kinetic energy, but also the potential energy, that is the space. You are not just increasing the measure of its movement, okay, but you're also increasing the space between them apart. That is the potential energy. Okay, how much energy does it take to raise the temperature for material? The amount of energy needed to raise the temperature depends on three factors. One, the mass of the object. The greater the mass, the more the heat energy needed to raise the temperature. Okay. The second one is the type of material it is made up of. There are some materials that have high conductivity, there are some that have low specific heat capacity, and so on. Now, these materials will need minimum heat compared to materials that have low conductivity or high specific heat capacity. Okay? Number three, the temperature change that you want. If you want to take the temperature to a higher degree, you need to heat it more. Okay, you need to give it more thermal energy. Okay, guys, I hope you understand this lesson. I want you to like the video and make a comment, ask question of what you don't understand, or comment on anything you want me to change. I'm going to effect it as soon as possible. Okay? Remain blessed.